Hello everyone. So in this video we are going to be discussing motion challenge. Now I would say this is the most interesting game. As in if you talk about game section of Gemini and you say any of like 8 games can be there. So this is one of the games which generally comes and this is the most interesting one. When I will tell you, like show you questions, you will yourself find out, okay, why this is so interesting. Okay, let's have a look at what a motion challenge would look like. So this is a question over here. You can see, let me just quickly introduce to you things for motion challenge. Okay, so you can say there is this red ball, I would say, and you have to put this ball, pot this ball in this hole. Okay, so let me tell you, red ball, you have to pot it over here. Now, in the passage, if I have to take the red ball and pot it over here, you can see there are few blocks or obstructions. You can see there is this orange block and there is this blue block and there is this violet block and green block. Okay. Now, besides, you can see there is, if you happen to look at these obstructions, you can see there is this 3 lines over here. So as in like 3 lines, you can hold this block and move it. So these are movable blocks. These are movable blocks. And what do I have over here is, you can see these are like fixed over here. So they have been nailed, they have been fixed. Okay, so these are fixed and these you can move. Now movement of these blocks, certainly the ball from here cannot go here unless these blocks are removed from the path. Okay, so these blocks, their movement is also restricted because it's a grid. Either they can go horizontally, they can go, a block can be moved horizontally or it can be moved vertically. Okay, so so what is the question? Red ball has to be potted into this black hole and you have to pot it in minimum number of steps. So students will definitely be able to find out a way whereas the red ball will travel to the black hole, but you need to find out in minimum number of ways. So I'll tell you, give you the example. Okay, let's say this is the question. Now let's have a look at what the steps counting will be looking like. Now, if you happen to look at this was my original question. This is where I start initial conditions. Now, what you can see is you have moved blue block up. So this is counted as a step one. Okay. So from here, you can see there is a transition and it has been moved up. You can very well see this transition has taken place. This is one step. Now, similarly, what they have done is they have taken this purple block up. So if you happen to see it, purple block up and purple block left. Purple block up and purple block left would make it look like coming over here. So now 3 steps. So first step was taking it up and the second step was taking it on the left side. So with this, with the completion of, let's say, these 3 steps, my positions of the blocks looks like this. Okay. Now what next is, I have taken this green block up. Green block up. Yes, this the student have to realize this, that you can certainly take the block above the hole. It cannot be placed above the ball, but certainly it can be placed above the hole. So what they have done is they have taken it above the hole and from there they have taken it to the left. They have taken it to the left. So the passage looks like this. So 5 steps already. The ball has not moved. What I have done is I fidgeted with, let's say, the blocks, but each time I'm fidgeting with the block, I'm counting it as a step. Okay. Then what happens if we go further? Uh, from here, you can see red ball. Let me just make it over here. The red ball was over here. It is taking a horizontal transition. So it can go in one transition as much as it can go uh, before it before it's like obstructed. So this is again one step, and now next step is taking it up vertically upwards. So if this process is followed, you can say there are 7 steps. Are we getting this? Let me tell you, what did we do? We took blue block up, and then we took a purple block up, and then shifted purple block left, and then we did this kind of a transition. So this is counted, and this is going to be like 7 steps. So it is written as 6 over here, so actually it is going to be 7 in counting. So that's wrongly written over there. Okay, now, so if I follow this, I'm not saying this is the right answer at the moment. I'm saying if you follow this, there is like you are able to move the you can say the ball into the black pot using 7 steps. Okay, now at this point of time the students would be saying, okay, they have some other way to do it. Yes, certainly there are other ways to do it, and certainly I'm not saying at this point of time. I was telling you like I'm basically telling you right now that this was one of the ways, and uh, and it is not like it is the minimum number of steps were followed. So if let's see if other steps, other ways will result into lesser number of steps. So back again to the problem again, and now the problem remains same. Now I told you before that I showed you in 7 step how is it possible. Now the thing is, it is possible in other ways as well, which might result into minimum, and thereby it is going to be the right answer, not the previous one. So let's see how it can be done. Again, I'll show the transition by the diagrams. Okay, so if you happen to look at this, this is our question, and let's get started. Which is the first step being followed over here? You can say this is they are moving this blue on the right. So this is one step. Okay, fine. Then they are bringing this orange block down. Okay, look for this. This is step 2. And what they did later on, this is like they got a passage. Once they brought it down, they got a passage like this. Step 3 would make it go up. Okay, so let me just put it back once again. This is the first step was to take the blue over here. Second was to bring the orange down. Orange looks like over here. Then step 3 is you take the orange from there to here. So this is step 3. Now once you have done it, there is a free passage you can see of like this. So fourth step is taking the ball up, vertically up, and fifth step is taking the potting the ball in the pot. So right now, last time we were able to do the same thing in 7 steps. This time we are able to do it in 5 steps. So the question is, what is the minimum number of steps? So this is the right approach, not previous one was the right approach. I showed you both. So as in to differentiate that, okay, it can be done in number of ways, but you have to find out the way in which it is done in minimum number of ways. So that is exactly what you have to demonstrate in class as well. There would be various different questions and students will get different answers, as in like some will get an answer of let's say 6 or 7, or somebody is getting an answer of 5. So then 5 is going to be the right answer, though it is doable, let's say in 7 steps as well, but you need to find out the minimum number of steps. Okay. Okay, let's take another question. Since you now know how the transitions are counted, things are, I believe, now clearer to you. We'll take this question as well. This is very, very simple question though. Okay, but I'll show you with the steps right now in the video so that you get more familiar. And once you are doing it, let's say as a practice in the class, things are sorted for you. Okay, let's have a look at this question now and we start counting the steps. So what is step 1? Step 1 was you make a transition for blue, it has been shifted to right. This is step 1. Step 2, orange. You can see orange from here is again shifted to right, which leaves me with a clear passage of red ball to black pot. And third step is I'm taking this red ball up and potting it in the plot. So this was fairly simple, 3 steps involved over here. Okay. Okay, so let me put the things back once again. Motion challenge is, you have seen right now, it's an interesting game. What is the basic question? The basic question is you need to pot the red ball into the black pot. There are two kinds of obstructions. One is movable, one is like fixed. And again, there is this liberty, as in like certainly the block, movable block can move in horizontal and vertical, take vertical and horizontal transition. It can go above the pot as well, but not above the ball. And then certainly you need to count the steps and you need to find that it will be done in how many minimum number of steps. So more questions you can try in the class, but try to ask the students to count it in minimum number of ways. I'm repeating it. There will be possibilities when they will find the path, but they are finding, let's say, the path in more number of steps, then more number of steps is not going to be the right answer. It has to be the minimum number of steps. Okay. Thanks for watching this video. Please watch all the videos for game aptitude, what I'm making, and that's game aptitude is going to be sorted for you guys then. Okay, thanks for watching the video.